direction change.
We don't know whether it is that star or different star.
That's what I said.
So this has to be the side, then we will not come to know that.
So that's the example. So imagine Venus is there, next to that a bright star. That's how you are identifying that star. The star which is right next to Venus. Now, many stars will be bright.
We can't tell it.
Different brightness. Okay. So have you seen you see the sun rising and setting, right?
Yes.
What about the moon? Moon also rises and sets? Moon is not rising and setting. If it rises, then it will just stay there, that's it, it won't happen. So it will rise and it will come forward. And then again it will go down again, it will rise forward.
Now by that time you are sleeping, that's why.
Or playing video games there. Your every answer is what I want. Okay, sir. So I'm going to teach you something now here. You have all seen the sun rising, setting, you have seen the moon moving. But have you noticed that the stars also move like that? You've seen that? So when the sun is also rising and setting, moon is rising and setting, even the stars are also actually rising and setting. Because there are so many points everywhere, you're not able to make it out, that's all. Okay. Now what I want you to do is, all of you have traveled by train?
Yes.
Right? Now imagine you're going by train. Make sound. Who's doing No one got a music? Okay, so imagine you're out traveling by a train and you're looking outside the window. What do you see outside the window usually?
Nature.
Yeah. So you see trees, you see small houses, you see farmlands, everything, right? So you're moving in the train. But when you look outside the window, what do you feel?
Trees are moving.
The trees are moving the opposite direction. So if the train is moving like this, when I look out, I feel like all the trees are moving in this direction. Correct? So now I want you to imagine that the train, instead of going straight, is going in a circle like this. Like the Kabul Park train is there, right? Going round and round. Imagine you're all sitting in that train. Okay? So when you look outside the train, you feel that the tree is moving in opposite direction. In a straight line, tree is moving and tree is gone. That's all. But if you're moving in a circular path, like this train is going round and round and round, and there is one tree outside, then when will you see this train? So this is a train. This is a tree which is there outside. Okay? This is a train which is going to come and go like this. So when I'm doing this, you have to tell me when you will be able to see the train. What you do is, whenever you can't see the tree, you shout no. Whenever you can see the tree, you shout yes together. Okay? Yes. So for one round, you see the tree once, correct? So if I come back one more round, you see the tree again. This is for a tree which is outside the track. Okay? Now, I am going to plant another tree in the middle of the track. So now there's one tree over here.
Yes.
Yes or no?
Yes.
So this tree is going round. This tree is always here. Train is going round. If there's a So if there's a tree at the center, you'll always be able to see it. If there's a tree outside, you will see it for once every round. After that, you won't be able to see it. Correct? Now same concept, we are going to just extend it to Earth. Earth is going round and round. So instead of sitting in a tree, you're sitting on Earth. That's all. So you have Earth like this. Imagine this is the train track now. So instead of the train track which is going round and round, you're sitting on Earth which is going round and round and round over here. Correct? So what will happen if there is a star over here? Instead of the tree which is outside, I am talking about a star. So there is this star over here. Now you have to again shout. Say this person is in India. India is here. All of you can see? Okay. So now you have to tell me a person in India when he can see this star. You have to shout yes and no.
Yes. No. Yes.
So again for the stars also same. Right. So for one round, we see the star once. Now what I am going to do is, you remember the tree which was there in the center which you were always seeing? Now I have a star which is over here. Tell me when the person from India can see it.
All the time.
All the time. Right? So there is one star which this person can see all the time. And the stars which are over here, he can see it only once for every round. Correct? Have you heard of the star called the pole star? All of you have heard? Pole star or North Star, Polaris. All of you have at least heard the name? All of you not heard? This star which I said over here is the pole star. Do you know what is special about pole star? Like you said, there are so many stars. How can we know the name? But you know pole stars name. So why do you know pole stars name? There should be something special about it, right? Yeah. So it is right over here. This is the Earth is rotating like this. Earth has an axis, North Pole, South Pole. Axis goes down like this, right? So if I just take the axis and extend it up, you will find the pole star. So which means for the people who are living over here, if the sun was not there, you will be able to see pole star all the time. And the other stars which are on the other side, you will be able to see it only once for every rotation of the Earth. Correct?
Yes. Did you understand? Yes, if you understood, because we'll ask questions back.
Okay. Okay. Shall I repeat again? Okay, so now imagine that we are all going to go on a journey now. We are going to go from pole star, from the North Pole, we are going to go to different places on Earth, and we are going to try and imagine what the sky looks like. Alright? Okay, so we have a person over here who is going to travel with us. He is going to go from the North Pole to all the places in the equator. Right? He start with North. He is standing right on top of the North Pole. So imagine you are also standing over here. Which is the star which is the right above? Pole star. Okay? So imagine this is the pole star. Now you are standing on North Pole and pole star is there. Correct? If I ask you all to raise your hand and point to pole star, how will you point? Raise your hand. Straight. Like this. Correct? So when this person is standing at the North Pole, he will point like this to the pole star. Right? So you all know the latitudes. Equator is 0 degree, then you have the Tropic of Cancer, 1.5 degree, and the number goes on increasing till 90 degrees. Right? So this is 0 degree equator, 90 degree poles. Okay? So if I am standing on the land over here, if you go to say an open ground or something, and you are standing on land, there is no trees, nothing outside, what will the shape of the land and sky be? Flat. Land will be flat. What about the sky? No shape. No clouds. If there are no clouds, or imagine if it is night time, what will the shape of the sky be? The shape? Flat like this. So land is like this, sky is flat like this? Like this? So something like a dome shape, like this, right? It will be like a half sphere, dome shape. Why does it look at that shape? If sky is appearing round, because Earth is round, when we see Earth, we don't feel it's round, right? Then why should sky appear round? Just try thinking.
We are standing on the Earth, so we can't tell that it's round. But when we see upwards, we can tell. Means we can sense that.
Yeah, that's right. Yes, you feel like it is round. But actually, if you go outside Earth, is there any round sky, anything there? Nothing like that, right? It's space everywhere. But why do you get this feeling that the sky is round? Atmosphere is all over. Okay, if I show you the moon and I show you one star and I ask you which is closer, the moon or star, which one is it? Moon. You feel like it's closer to you, right? When you look at it. If I show you two stars, different brightness, and I ask you which star is closer to us, how will you tell? So bright star means it's closer? Okay. If I take two bulbs, okay? This is a big bulb which is very bright, and this is a small bulb which is little dim. I'll keep this very close to your face, and this one I'll take it very, very, very far away. Which one will appear bright to you? Big one or small? This is very close, this is very far. This one will still appear bright to you. Yeah, it's big one, but it's very far away, right? Okay. Which is more brighter? Traffic signal is brighter, or car headlights are brighter? You are standing next to a signal. Car is 2 kilometers away. Which one will you see?
Traffic.
But car bulb is bigger, right? 2 kilometers away. bulb which is very bright, which is little bright but very close to you, and another bulb which is bright but very far away from you, this will appear to be brighter because this bulb is very far away. You won't be able to see it as bright. If I bring it close to you, you will be able to tell, okay, this is brighter or this is smaller. Otherwise, depending on distance, you cannot judge which one is actually closer or which one is far away. So the same case with stars. There can be a bright star, there can be a dim star. The dim star might actually be brighter or actually be more powerful, more hot. But because it's so far away, we are not able to see it as so bright. There are so many stars which are actually, much brighter, much hotter, much bigger than our sun. But the sun is closest to us. So when the sun rises, what happens? Even though there are 6,000 stars over there which are brighter than sun, you cannot see any of them, right? Only because sun is closer to us. So same way with the stars also. So checking whether it's bright or dim, you cannot tell what is the distance. So there are two stars. So now by brightness you cannot tell. You can't say this is brighter, so it's close to me. Then how will you tell that it's everything looks point.
How do they calculate?
No, I'm just asking. So if you just look at it, will you be able to tell? If you just look at two stars, no instruments, nothing. You're just looking at two stars, will you be able to tell which one is closer, which one is farther? Bright one. Will you be able to tell? That's all. I'm not asking you have to tell me. There are stars which are brighter than sun, 1,000 times bigger than sun. But they appear like one tiny dot in the sky because they are very far away. Color won't tell you distance. Color will tell you other things like what the star is made up of, which element is there, or which life cycle it is, things like that. But it won't tell you distance. I'm just asking, will you be able to tell? Yes or no? Just looking at it, you're not using any big instruments. With the eye, you're just looking at it. Will you be able to tell that this is closer or this is far? So just the eye, you cannot tell that, right? So if I have two objects, now we have 3,000 stars in the sky, which we can see with the naked eye. There is no atmosphere. So if I have 3,000 stars, I'm not able to tell which one is closer, which one is far away. Then what will happen? There's one star here, one star here. This might be close, this might be far. But when I see from Earth, everything looks like it is at the same distance. So you feel like, if you see there are 3,000 stars and everything is at the same distance from you, what shape is that? You're at the center of what then? I'm standing here, everything is at the exactly same distance from me because I can't tell the distance. So what shape gives you that? If it's a square, for example, if a square like this, if I'm standing here, the distance from here to here and distance from here to here is the same? So which shape will give me? Circle, right? So if I'm standing in the middle of a circle, everything will be at the same distance from me in every direction. In 3D, what shape is that? 2D is circle. In 3 dimension? Sphere. Right? So when you see the sky, what happens? There are 3,000 stars here. You don't know the distance to any of the stars. You can't tell. So you feel like you are standing in the center and all the stars are at the same distance from you. That's why you feel like the sky is in the shape. Dome shape. The sky is actually not like that. It's only because you cannot tell the distance to the stars. So everything looks like it's in the shape around you. Okay? Don't look very tired. Breakfast? Want to take 2 minutes break? Sure?
You will have it.
Okay, so we were doing this, right? The person was standing on top of the pole, and when he was standing on the pole, how was he pointing to pole star? Straight up. So that is his pole star, and he will point like this. So when he is standing at 90-degree latitude, so this is my horizon, this is my land, my sky is going like this, like a dome, and this is called the horizon, the line below which you cannot see the sky. Okay, where you feel like the sky and the land are meeting each other. Right? So, with respect to my horizon, this is 0 degrees. Then what angle is this? 90 degrees. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. 90 degrees, correct? So, if he is standing at the pole and he is pointing like this, which angle is this? 90 degrees. He is standing at 90 degree latitude and he is pointing to pole star, which is also at 90 degrees. Now, the pole star is still over there. Far away, very far away, okay? all have come to the equator now. I am asking you to now find and point at the pole star from equator. How will you point?
How will you stand here?
That's it.
Like this.
All of you have to show. Like this. So when he comes here, he'll have to do like this. Correct? Now he's pointing. So when he's standing at the pole, he has to point like this. When he comes to the equator, he has to point like this. So if you're standing at the pole and seeing, pole star will be right above your head. Below the equator, you can't see it. Will you be able to see? If this fellow comes over here and pole star is here, will you be able to see? So only up to the equator. And when you come to equator, pole star will be here, right near the horizon. If it's too cloudy or there's too much atmosphere, you won't be able to see. So this is 90-degree latitude. Pole star is at 90 degrees like this. When he comes to equator, what degree is this? 0 degree. What is the latitude of equator? 0. So 0 degree equator, 0 degree pole star. 90 degree north pole, 90 degree pole star. So if he travels to some place which is 45 degrees, where will the pole star be? 45. Show your hand. Show using your hand. All of you. So somewhere between 45 degrees. So when I go to the north pole, pole star will be here. When I come to 45 degrees, my pole star will be here in the sky. When I come to equator, the pole star will be here. Any of you know the latitude of Bangalore? Approximately. Are we close to equator, above, below? Above equator. Okay. Above the Tropic of Cancer also? Below that. Below. What is Tropic of Cancer value? So our latitude is between 0 and 20. So for Bangalore it is actually around 12 degrees. So if you are standing in Bangalore now, it is night sky. Where is the pole star? Point. Point and try. I don't understand that. So you have to show with your hand. So approximately 12 degrees. Right? So when you see from Bangalore, pole star will be somewhere 12 degrees. Alright? So now you want to remember that, right? The tree which is outside, you will see it once when you go. The tree which is at the center, you will see it all the time. So if I see from Bangalore, what will happen? I will see the pole star is always over. Because sun is coming at home.
Just in textbooks, no? Where is North Pole present means in the textbook language they say northern hemisphere. They have to know the term. Where is pole star is? In textbook they say only northern hemisphere. They have to understand what is northern hemisphere. Very easy takes. Like northern hemisphere.
This is the northern hemisphere. Above the equator, till here is northern hemisphere. This half of the globe. This half of the globe has the southern hemisphere. In that north pole, Tropic of Cancer, equator. Then equator, Tropic of Capricorn, south pole. Okay? So because we are in the northern hemisphere, I am only talking about pole star. So if we go to south, there is no pole star over there. There is no point in discussing once we go to the southern hemisphere at all. Okay? So now, this person is standing over, right? He is seeing the star which is over there, which is always fixed. But the earth is moving round and round. What will happen to all the stars which are around pole star? Will it also be in the same place? What will happen to those stars? How will they appear there? They will be moving. How will they? They go zigzag, zigzag, like a speed racer.
Opposite.
Okay. So, say this is, I am still, we don't go to North Pole again. Pole star is over here. Okay? The red one is the pole star. I am going to use another color to represent the other stars which are there in the sky. And I am going to show you how it will be in the North Pole. When you go to the North Pole and you look at the stars, this is how they will be moving. Okay? Pole star is here. Pole star does not move. Pole star will be in the same place. It won't move. Alright? You want to see what happens to other stars? I want to show you. Yes. Yes. See, these are other stars. They will go round and round and round like this. Pole star will always be there. Whatever stars are there around it will go round like this. So if they finish one round, that will be Earth's one rotation. The stars are there, they are actually not rotating because we are rotating on Earth. Just like how you see the tree outside moving in the backward direction, you see the stars going in the opposite direction. Okay, so Earth will go west to east. That's why everything is going from east to west. Because Earth is rotating in that direction. So at the pole, what will happen? All the stars will be going like this. Round, round, round on the ceiling, right over. Now I am coming to equator. Where is the pole star? At the equator? Point. Okay. So say you can all see this part of the pole. I'll say that this is the horizon. Pole star is coming to horizon. Okay, below this you can't see anything. So whatever light comes below this, assume that you can't see it. Now I'm going to bring the other stars. Pole star will always be there. As the Earth rotates, what happens? So look at one of the stars over here. What is this star doing? You cannot see the star now? It's zero. So what happens to some other star? If there is one more star that is far away here, how will that star move? If it is over here, can you see it? Now? Yes. Keep saying yes, sir. What is this? The star is rising, star is setting. This is what happens with the sun, moon, everything. So whatever you see over here, the star is rising over here, poles are always here. It's not moving anywhere because it's right around the axis. So the other stars, they will appear to rise, they will go like this, and they will appear to set over. Right? So the stars which, but if you go to North Pole, will you be able to see rising and setting? Can you? Will you? So if there is one pole star here, everything is going like this, right? So if one star is here, that star will be going like this. But when I come to equator, what happens? Star is going like this. So Bangalore, what will happen? Bangalore is what degrees? 12. So pole star approximately 12 degrees. Now other stars will go like this. So the stars which are close to pole star will always be going out and down. The stars which are very far away will be rising and setting. You all remember this, right? If the pole star is in Bangalore, it will be at 12 degrees. You know why pole star is important? The picture is there and the axis over there, fine. But why is it important to us? Any idea? Yeah, it's there, but it's simply sitting there, right? It's not doing anything for us. To identify? Yes, correct. Yes, that's correct. See, suppose I told you that Bangalore is 12 degrees, point to pole star. Where did you all point? 12 degrees. Now you go to a place where you don't know the latitude. You don't know where you are. You are completely lost. But you find the pole star. What can you find from that? You say you find the pole star somewhere here. So you can approximately tell which latitude you are. If it's over here, you just measure and you say, okay, this is approximately 30 degrees. So I must be there somewhere in 30-degree latitude. Correct? So the pole star was important for navigation. In the ancient times when people were traveling by sea, suppose they start from here. They start at 45-degree latitude and they want to go in a straight line and reach this other place. What they will do when they are starting, they will check where their pole star is. We'll do. Okay, so they see where the pole star is. Then they will start sailing. And every few minutes or every 1 hour, they'll keep checking whether the pole star is in the same height. If the height increases or decreases, if they go like this, height will increase. Then they will come back. If they go below this, height will decrease. Then they will again come back. So by continuously checking where the pole star is, you will know which line you are moving in the way. So it was very useful for navigation during that time. So we have some kits and activities now. We will give you one of that. Each one of you will give you one, which you can go back home and make yourself. Now we will show you how to use it and how to make it.
You are used to learning how to use it.
All of you got? We have few kids which are already made in here. Now for explanation we will give one to each small group. So you can have a look at it, you can see how it is made and you can try using it. After the explanation I will take it back. Have a look at how it is made so you can go back home and make it on your own also. You have to share this, okay? If you want to share, if you want to turn and sit down also you can sit. So you can do benches and chairs. You can
You need to make it
Okay, so all of you take out the books what you have, what we have given you now. Be careful, there are some clips and all inside in the folder. Open to a page where you have something like this. What is written on it? Star form. Right? So you just learned about pole star, right? And you know that whatever is around pole star will go around and round and round in circle. One circle for every one earth spin. Earth will spin in how many hours? One spin? 24 hours. One day. Right? So that one day, that's how you go like this. Okay? So you ask how to identify pole star, right? You all see this image over here? Have you all heard of one constellation called Big Dipper, Big Bear, Saptarishi Mandala? You all heard? Okay, you see the center over here? That represents the pole star. The center where this clip has been moved. Okay? And there are some stars, there will be lots of stars around here, right? Around pole star, lots of stars will be there. We have shown just few stars right now. This is one constellation called Big Dipper, which looks like a big spoon. And this is another constellation called Cassiopeia, which looks like a capital M, or if it is inverted, it looks like a W. Yeah, right? Yeah. So if you see in the sky, you will see pole star, you will see Big Dipper, you will see Cassiopeia. So as the Earth is turning, what will happen to Big Dipper and Cassiopeia? They will be turning, correct? So pole star will be here, Big Dipper will be going like this round and round, and the Cassiopeia will also be going round. It will be something like this. This is Big Dipper, this is Cassiopeia. So one circle in 24 hours. Correct? So this is important because using this you are going to identify the pole star. These two constellations are very easy to identify. Big Dipper, it looks like a very big spoon in the sky. The other one is a capital N. You see that they are opposite to each other, right? So if suppose say you are in a place like Bangalore, or if it's Bangalore, pole star will be somewhere here. If it is equator, it will be like this ground, correct? So if say you are in Bangalore, pole star will be somewhere here, correct? Now can I see Cassiopeia from Bangalore? This one, capital N. Can I see this from Bangalore? This is below ground, this is above ground. This is my horizon. Can I see Big Dipper from Bangalore? Yes. After some time, what will happen to this? This will set. And what will this do? Then you can see Cassiopeia, right? So from any place, these two constellations have been chosen specifically for them because they are exactly opposite to each other. And this one is setting, this one will be rising. So any given time, either you will find this or you will find at least this. So if you find any one of them, you will find the pole star. So if you see here, you see one dash line over here, dot 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 dot, going from Big Dipper. So you take this big spoon, take the last two stars and just extend it. If you take it to pole star. So suppose Big Dipper is not there, then you find this M. Okay? You draw a line to bisect the angle of this triangle. You have all learned in geometry how to bisect an angle. So you just bisect this angle, that will take you to pole star. So that pole star is difficult to find a little bit because it is not a very bright star. So if you are not able to find it easily, then you find either Big Dipper or this constellation. And then just join the line and that you will be able to find pole star from it. Okay? So after finding pole star, now using this, we are going to find out what is the time at night. Which month is this now? July. There are months written over here everywhere. Hold July. Hold it like this, July. Okay. And now can you rotate this one? Okay. When you rotate it, make sure that July is always on top. You are checking for July. Say this is what Bangalore it is like. Okay. This is the ground. I cannot see Cassiopeia. I can see Big Dipper on top. When I go out at night. So what I should do is to find out what is the time in Bangalore. Hold July on top and rotate this till this pattern matches the same pattern. See? So pole star, Big Dipper is on top to the left. So hold July on top, rotate this till Big Dipper comes on top to the left. If you have any doubts, ask them, they all of you understood? So Then we have to put it together like this. Fold this, fold this, fold this. 12-degree fold and keep it. Then there is a small hole on top. Put some pencil or stick or pen or anything to it. Please put this pencil. What is written over here? That tells you sunrise to sunset, correct? So now what you have to do is make it like this. Put some pencil or pen or anything over here, and you have to keep it on the ground. This one should be facing north. Okay? So facing north, keep this on the ground. So say this is the sun. This is the sun. Okay? I am going to make the sun rise from east, go above and set to the west. You just observe what happens to the shadow of the pencil when you do it. Okay? So now sun is rising. Where is the shadow? Now it is afternoon. When it is right above your head. Now? 6 a.m. So from sun, when sun was rising, 6 a.m. Noon, 12 p.m. Sun is setting, 6 p.m. So using this, you will be able to tell what is the time. Right? Only thing is make sure this is facing in the northern direction. Otherwise this will not be east and west. Okay? And what is the next one? Star. Next one starting or how many of you have solar motion? Something like this, right? You know star beam. Yes. Whatever you see on this, there are so many different things. So top, what do you see? Topmost. Above line there is something else. The other sheet. Back side there is one more sheet. That has to be put like this. All of you will get one demo. Please you can have a look at it.
Two more.
All of you got? You see the top, what is that? This big circle. What all is written on that? We have months, February month. Below that, dates are given. And then the other cardboard, time is given. There are 2 times mentioned, right? What is top and follow only what is given on top. You see there is 1 a.m. below that 2 a.m. Midnight below that 1 a.m. Follow only the number which is given on top. Don't follow which is given below that. Okay? Below 1 is for something for US, not for us. Okay? So now what you have to do is this one will help you identify. You all have seen the stars, but you told that you don't know which star is which one, right? You don't know to name the star. You don't know to identify different constellations. So using this, you'll be able to identify all the stars in the sky. What you have to do is, so which month are we in? Let's check for today. Rotate this, find July. This can be rotated separately. Rotate this and find July. What is the date today? So July 5, right? Find July 5. All of you got July 5? Yes. For what time do you want to check?
Correct.
How do you want to check?
Now you can't see any star.
What time do you want to check? You found 8 p.m.? Now take this, rotate it till July 5 and 8 p.m. match. Okay, July 5 is here, 8 p.m. is here. They are matching, right? And on this you have facing east, facing north, facing west and facing south written. Now imagine that this is north side. Okay, let this be north. Take this, hold it above your head. Hold it above it, flat. Wherever the facing north should be facing that side. Where is facing north? Okay. So now, today night, July 5th at 8 p.m. if you go out and if you keep it like this facing north side and if you compare what is there in the small window, we have oval shaped window, whatever is visible here will be visible in your sky as well. So using this you can identify all the different stars which are there, you can find out which constellations are also visible. Okay, so you just have to hold it like this and say, okay, bright star, there is one bright star here. So that is our universe. Another bright star here, that is Vega. So using this you can identify all the stars and the constellations. So this way you can check for the whole year. Any day, starting from 5 p.m. till 7 a.m., you can check what all stars will be visible. So in this also if you see, center of this thing is North Star. That's the pole star. If I rotate this, what happens? Pole star is always in the same place. Everything is going round and round. Pole star. We just have some, you all understood that, right? Poster, center, everything goes on the ground. We have some photographs which you can see. These photographs were taken from different parts of Earth. So they will show you that when you go from one place to another, pole star is shifting, all the stars are going out and out. We have 5 sets with us, so you can just share it and you can have a look. See if you can find out which photo was taken in which latitude by looking at where the pole star is. You can get this.
So what is this?
No, why the star is appearing like a line over there? The camera was kept open for a long time. So when the star went from here to here, the entire thing came in the camera. If I just click once and leave it, only one point will be there. Sometimes you see when you take photos of people and moving, will be shaken. Something like that.
be started. It will not be started. When you have the lines the problem is the lines when you just close your eyes, the images which you have seen, crossing your brain for only 1/60 of a second. The same is always. You don't exactly see it. But camera in that moment you can even study it. So whatever you have seen for your it can combine all of that light together. So the star would have moved one by one. It's not the star, it's the
Why we are not seeing birds?
this would be more or less nearby and this would be also so these are the photos.
If the whole star is you can see part of the star. No, you cannot see. Because it's slightly above, then can you see?
So you have these identify where the
So you see where
places are right above.
it should be on.
When you can see the places,
So what is the
you can imagine.
So you are at the north.
And if you look, you can see the stars in the you can just tell the sky was continuous.
Thank you.